Have you seen the price of halibut in the supermarket lately? It's crazy! Hey, I could catch my own fish for free. I'll just go out in my... I guess I'll need a boat. That's kind of expensive. And then I'll need to take time off of work. That'll cost me too. And man, I'll also need a fishing pole and some hooks and some bait and a fishing license, of course. And I may want to have a guide show me where the fish are. Okay, there may be some hidden costs involved in catching my own fish. You know what else has hidden costs? Wireless SoC design. Sure, you could try to do it yourself from scratch, and that would be awesome, but you might find out that there are quite a few hidden costs, some of them quite scary, in doing an SoC. Hi, I'm Amelia Dalton, host of Chalk Talk. Today I'm chatting with Joe Tillison from Silicon Labs about 6 hidden costs of wireless SoC design. It may just send you back to the supermarket. And before we get started, don't forget to click that link. There you can find out more information and get your Silicon Labs SoCs at Mouser. Hi, Joe. Thank you so much for joining me today.
Oh, thank you. I'm very glad to be here.
Okay, Joe, I have to admit I'm excited about this topic. So many teams I talk to are struggling with this make versus buy thing. There are a zillion great SoCs on the market that cost almost nothing, but there are also a lot of really capable modules that could save us a ton of design work. And engineer to engineer, there's always a temptation to just roll up our sleeves, grab an SoC, and get to work. How can we get some perspective on this?
Yeah, and we actually see a lot of engineers make that decision in different ways. We also sell some of those really inexpensive SoCs, but more often than not, they're just looking at the cost of the SoC compared to the cost of the module. And so we put this paper together that we call 6 Hidden Costs in a 99-cent wireless SoC, just to help explain to engineers what some of those hidden costs might be that they should take into account.
Okay. Cool. I'll read the white paper. That sounds like a really good resource. But give me a quick cheat sheet. What are the advantages and disadvantages of SoCs and modules?
Okay, yeah, here's the cheat sheet. The bottom line is that you would design with an SoC if you want the lowest possible cost of your bill of materials. But that comes along with a little bit of a volume burden too. You really do need to have some high annual volumes. And you need to have a pretty good R&D budget because you're going to spend some money up front. That includes the ability to test antennas and having RF experts on staff. On the other hand, a module would be better if you need to get to market quickly and you don't have any tolerance for design risk, which again we see in a lot of cases. You don't have the RF experts on staff or the knowledge in-house to be able to do it yourself. And you don't want, maybe even if you do have those experts, they're busy and you don't want to bind them up doing RF design.
Okay, so let's get specific on the SoC front first. What have you got for me?
Okay, like I said, most of the time it comes down to the cost. So one of the things that we do to support our customers who do want to do a chip down design is we publish an application note that shows them the absolute minimum cost of their bill of materials using our Blue Gecko part. That part is unique because it has a lot of the external circuits you would normally require integrated on the chip, like RF power amplifier and the balun and a DC to DC converter. So even with that, you're going to have to add a couple of crystals, some external passives, an inductor, an antenna, and maybe even a shield if your application requires that. So right there, your 99-cent SoC has gone up to $2 because you're going to add from 50 cents to $1 to that bill of materials depending on your volumes.
So walk me through the make versus buy here with a real example.
Sure. So this is sort of your traditional break-even analysis chart. There's a couple of data points on the bottom at 10K, 100K, and 250K. I won't go through those numbers, but they are based on real module and SoC costs. And the premise is that you're going to spend more money upfront on the SoC design than you would on a module design, but you're going to spend more on the module over the long term as your volumes accumulate. So at some point, those two costs cross over each other. And today, that break-even point is somewhere in that 200 to 250K units region that we call the break-even zone.
So it seems like it's not just about cost, though, is it? Aren't there a lot of other things that factor into the decision?
Yes, you're exactly right. So everybody cares about cost, but there's some of these other considerations, like what about your product launch being delayed? What if you have to live with an inferior RF design because you didn't have any more time in the schedule to get it just right? And what if you have to go through your compliance testing again and again to get that to pass? Again, modules remove those unknowns and reduce that risk. And to sort of make that point, you can find these type of teardowns that are shown in a picture. This one is of an iPhone 6. Apple today is shipping somewhere between 60 and 70 million iPhone 6s per quarter. So clearly they have the volume to justify an SoC design, but they don't. They use modules for the reasons we just talked about.
Okay, let's get specific about some of these hidden costs you're talking about.
Okay, so hidden cost number one is engineering. RF engineers are very specialized people, and specialized design engineers are expensive. So a burden salary for an RF engineer could be anywhere from 100 to 200K a year. But on top of that, no two RF designs are the same. Every RF design has to go through some of these challenges, choosing the right antenna, getting the performance to work the way you want it. Even choosing the antenna supplier can be a pretty tough decision. But also getting the PCB trace, the shapes and the lengths just right, getting the design constraints locked down, and there can even be fab constraints that you need to define on your final design. Performance tuning is usually an iterative process, and you've got to take into account things like the impact of housings, batteries, and so forth on how that RF performance is going to work. And again, we provide app notes to help those RF engineers to get that done, but a module design has already been designed by those RF experts, so it takes that hidden cost away.
That makes sense. It's hard to get every expert you need on every design team. What are some of the other hidden costs?
So here's hidden cost number two. You've got to give that RF engineer some specialized lab equipment so he can get his job done. And here's an example of some of the equipment that you're going to need. Now, to be fair, these are the kind of pieces of equipment that you need to do RF compliance testing, like specialized antennas, positioners, spectrum analyzers, and so on. But even if you don't have this equipment in-house, then once you get to a test lab, you've got to pay to rent that equipment. And that engineer will need some of this equipment at his desk just to get the design done. So again, this is a hidden cost that you don't get with modules because they've already been through that design. They've been fully tested and the design's been qualified and is ready for production.
Good point. Just the scopes can be amazingly expensive. Let's go on. What's another hidden cost?
So another hidden cost is the effort to get the PCB layout and the antenna matching exactly right. You know, it is a common question, well, how hard can it actually be? Again, we provide app notes for those engineers that help explain that. And if you look at that diagram there, you can see what a model looks like for the RF circuit on a PCB. The point here is that it's very nuanced. Every component in that design has parasitics that can either filter or pass RF, including the PCB copper itself. So just the shape of the copper can change the way that the RF performance works. And because of that, getting the tuning optimized just right is an iterative process. You've got to design it, build it, test it, probably design it again, test it again, and so forth until it's finally exactly the way you want it. We call that hidden cost number three because, again, this is already done for an RF module. And doing a layout for an RF module, you just have to follow some really simple guidelines for placing the module itself. And usually the antenna design by that point is pretty robust to other PCB materials.
Yep, a lot of teams really struggle with things like signal and power integrity in their PCB layouts. When you add in the RF, it opens up a whole nother can of worms. Okay, next hidden cost.
So the big one, and probably the most obvious one, is regulatory approvals. Regulatory approvals vary by country. Here in the US we have the FCC, and in Canada they have Industry Canada. CE covers a lot of the European Union and so forth. The point being that every product you make has to be tested for compliance in every country where you're going to sell it. And sometimes the standards change. In Europe, the standards have changed twice in the last couple of years and require you to go back and recertify them. So the advantage of using modules is that you inherit those certifications from the module certifications. But then also you need to keep in mind that a lot of products that implement Bluetooth, Zigbee, and Wi-Fi have to also be certified by the Industry Alliance. You get the benefit of those certifications with a module too.
I hadn't thought about that one. Having all the regulatory hoops cleared before we even start would be a huge help. Give me another one.
Okay, so here's hidden cost number 5, the revenue that you can lose from delaying your product launch. If you look at that flow diagram, this is representing that iterative design process that I was talking about. Design it, build it, test it. If you don't pass, go make some design changes and so forth. That process can take anywhere from 6 weeks, optimistically, up to 16 weeks, with a pretty high risk of having to do rework. If you design with the module, which is that red line, that process can be as short as 2 to 3 weeks with really minimal risk of rework. And so if you look at the chart, and this is a little less intuitive, and maybe even we could debate a different model for how you calculate this, but the message we're trying to show here is if I take that 12 weeks and compare the cost of the SoC versus the cost of the module, you obviously get more revenue quickly with the module. And if you look even at the 1 million annual units point, the lost revenue that you have from 12 weeks of missing the market window versus the amount of money you saved on that bill of materials are almost even. So again, it might be less intuitive, but even at high volume, sometimes there's that lost opportunity cost that's pretty significant.
That makes sense. We always hear about how much it costs if our project is late. Having a shorter schedule to start with should be worth a lot of revenue, right? You said there were 6 hidden costs. What's the last one?
So the last hidden cost is your supply chain management and assurance. If you look at the SoC production, managing that means you're going to have 15, maybe more components that you've got to manage. You've got to keep your inventory balanced with your own product's demand for production. You're going to have multiple component vendors that you've got to manage. They might have different lead times, different minimum order quantities. And in production, you can have different fab, test, or quality issues that may pop up, and yield issues, so you won't get 100% yield in your production. With the module, you've got one vendor, one part number, you can manage the lead time, and you get a product that's already been pre-tested and calibrated if necessary, and you're getting products that have already been through tests, so the yield issue is removed. So yeah, a module vendor basically manages those supply chain issues for you.
Okay, Joe, this gave me some really great perspective on the SoC versus module decision. Let's hit the high points just one more time.
Yeah, so just to summarize, how to choose between a module and an SoC comes down to how much volume that you're going to produce, what the resources are that you have available to you, and your tolerance for risk. But those hidden costs come into play too. Things like having the right engineering staff, having the right equipment for them to use, having to go through multiple design cycles, and the risk of having lost time to market and potentially losing market share to a competitor that came out quicker than you. For us, we're sitting in what we call the best of both worlds because we do offer modules for the lower volume customers and for high volume customers that don't want to take on that risk. But we also offer the SoC option for customers who really do want that lowest bill of materials cost. And what's nice is our software doesn't really care whether it's the SoC or the module. It's pretty seamless either way.
Fantastic. Well, I think that's all I have time for today. Thank you so much for joining me, Joe. It was a pleasure speaking with you.
Oh, thanks for having me.
And before we go, you didn't forget to click that link, did you? There you can find out more information and get your Silicon Labs SoCs at Mouser. For Chalk Talks, I'm Amelia Dalton from EE Journal. For more Chalk Talks, head on over to YouTube, keyword EE Journal, or check out the on-demand section of eejournal.com.